Hey students, welcome to math.serve.com, and this clip we're going to be going over problems 26 to 30 of the ACT Math Practice Test. Alright, let's take a look at problem 26. It reads, in the figure shown below, the measure of angle BAC is x plus 20 quantity degrees, and the measure of angle BAD is 90 degrees. Question, what is the measure of angle CAD? So let's go ahead and annotate the diagram that we have here with the information that's given. So the entire angle BAD right here, that is 90 degrees as we would expect since it's 90 degrees. Okay, and then we're also told that angle BAC, this is angle BAC right here, angle BAC measures x plus 20 degrees. So the question is, what is the measure of angle CAD? So what is this angular measure right here? So this is the unknown. Alright, so let's go ahead and write down the formula that's going to guide our problem solving process. This is known as the angle addition postulate from geometry. Okay, angle addition postulate. So what does that tell us? Well, it tells us that the measure of angle BAD, the entire combination of the two angles, is equal to the sum of the two angles that makes up the combination. So it's equal to the measure of angle BAC plus the measure of angle CAD. Okay, so according to the angle addition postulate, we can write this equation. Now let's indicate what the different values that we know are and the value that's unknown. So measure of angle BAD is the right angle, that's 90 degrees. Measure of angle BAC, we're told that that's x plus 20 degrees. And with this given information, we have to determine what the measure of angle CAD is. So that's a question mark. Okay, so let's go ahead and set up our equations. So we have the measure of angle BAD. So we have that already written. Let's just write it again. So measure of angle BAD is equal to measure of angle BAC plus measure of angle CAD. Alright, let's go ahead and substitute. Measure of angle BAD is 90 degrees, and that's equal to measure of angle BAC, which is a quantity x plus 20, plus measure of angle CAD. Our goal here is to get measure of angle CAD isolated. To accomplish that, we'll have to move x and 20 to the left side of the equation. So we're going to subtract x from both sides. That will get rid of the x on the right side. And then subtract 20 from both sides also. So what happens when we carry out this operation? If we do that, what we're going to have on the left side of our equation, we're going to have negative x plus 90 minus 20 is 70. On the right side, these all add up to 0 equals the measure of angle CAD. Okay, so we can rewrite this as a measure of angle CAD using the commutative property of addition. This can be written as 70 minus x. 70 minus x degrees is the measure of angle CAD. Our answer is option letter G. Alright, let's take a look at question number 27. It reads, what is the perimeter in inches of the isosceles right triangle shown below, whose hypotenuse is 8√2 inches long? Okay, so we're asked to find out what the perimeter is. Now what we're going to do first is talk about what an isosceles triangle is. Okay, just a real quick reminder. What is an isosceles triangle? Recall. An isosceles triangle. Oh, let's be specific here. This is not just any isosceles triangle. We have an isosceles right triangle. Alright, so an isosceles right triangle has two congruent legs and a hypotenuse. Okay, the hypotenuse is normally going to be opposite the 90-degree angle. Okay, so what are the formulas that we're going to be using for this problem? Well, these are the formulas that we're going to use. The first one is the perimeter of a triangle. What is the perimeter of a triangle? The formula for the perimeter of a triangle is simply the sum of all the three sides. Okay, sum of the measures of all three sides. And then another formula that I like you to remember is something called the Pythagorean theorem. You might have heard of that before. Pythagorean theorem. This applies only to right triangles. Is applicable here because we have a right triangle. The Pythagorean theorem is basically a theorem that relates the legs of a right triangle with the hypotenuse. Okay, so it's basically the hypotenuse square c square equals the sum of the squares of the legs, a square plus b square. Alright, so let's direct our attention to the triangle. So we have a triangle like this. This is the right angle right here. These two are the legs that are congruent, and the hypotenuse is 8 root 2. Okay, so let's call this side x and call this side x. Okay, because the two sides of an isosceles triangle are congruent. Okay, so what we're asked to find here is the perimeter. The perimeter is the sum of the measures of all the three sides, so it's basically x plus 8 root 2. Okay, so our perimeter is going to be x plus x is 2x plus 8 root 2. So in order for us to solve this problem, we need to find x. We don't know what x is, okay? So we're going to use two methods to find x. So the first one, we're going to use the Pythagorean theorem. Okay, method 1, Pythagorean theorem. Alright, so what is the Pythagorean theorem again? We mentioned it earlier. It's a squared plus b squared equals c squared. So if we apply that idea to this problem, so let me just draw another right triangle. So we have the triangle again. So we have this is x, and this is x, and this is 8 root 2. So which is a, which is b, and which is c? For the Pythagorean theorem, c squared equals a squared plus b squared. So what you want to remember whenever you're using the Pythagorean theorem is that the longest side is always c, okay, and the shorter sides are a and b. It doesn't matter which is which, okay? So this is c, and this is a, and that's b. Let's substitute these measures into our Pythagorean theorem. We have 8 root 2 equals a squared, which is 8 root 2 squared. C squared is equal to a squared, x squared plus b squared, x squared. Now, how on earth do we square 8 root 2? We have 8 times root 2, so when we are squaring these, we'll apply the power of a product property of exponents. We're going to raise 8 and root 2 to the second power. If you raise 8 to the second power, you get 64. If you raise root 2 to the second power, you get 2. Alright, x squared plus x squared. Imagine you have a 1x squared here and 1x squared. Combine these two to get 2x squared. Okay, now let's simplify further. 64 times 2 is 128 equals 2x squared. We can divide both sides by 2, divide by 2, divide by 2, and that gives us x squared is equal to 64. To get rid of the square, we take the square root, and that gives us x equals, anytime you take the square root of a square, you have plus or minus, okay? So plus or minus 8. Now, since x represents the measure of a triangle, a length, it has to be positive, okay? So x is going to be positive 8. Now, this is one way you can find x using the Pythagorean theorem. It's not the fastest way, though. There's another way that you can find the measure of x, and that is using special triangles. Okay, so method 2 is special triangles. You just have to remember your special triangles, and then you can apply that here. Alright, so what's the special triangles? The special triangles are used for 30, 60, 90 or 45, 45, 90 triangles. Now, 30, 60, 90 or 45, 45, 90, which is applicable to this scenario? It's definitely the 45, 45, 90 triangles, because that can be used to find side lengths of isosceles right triangles given any side. Okay, so this is an isosceles right triangle, so that basically tells us that this is 45 and this is 45, and we have 90. So 45, 45, 90 degrees is the special triangle that we are going to be using for this problem. Okay, so you just have to remember what the special triangle is, and then we can set up ratios to find out what x is. Okay, so the hypotenuse is always root 2, so you put this over root 2, and then the legs are both 1, so 1 and 1. Okay, so we can just set up a proportion to solve for x. So let's go ahead and set it up. So to find x, we're setting up a proportion using the standard 45, 45, 90 triangle, 1, 1, root 2, and the x, x, 8, root 2 similar triangle of the special triangle. Okay, so we just said x over 1 is equal to 8 root 2 over root 2. Okay, and then these root 2's divide out, and you have x is equal to 8. So using the special triangles is basically the fastest way to do it. But if you do not know how to, or if you don't remember your special triangles, you can always use the Pythagorean theorem to solve for x. Okay? Alright, so that's not our answer. We're looking for the perimeter. Alrighty? We've just found the main ingredients we need, which is x. So now the perimeter, we talked about this earlier, is 2x plus 8 root 2. So how do we proceed? We know that x is 8, so we substitute it here. So our perimeter is going to be 2 times 8 plus 8 root 2, which is 16 plus 8 root 2. And that's our perimeter. The answer for number 27 is option letter E. Alright, let's take a look at question 28. It says the equation y equals ax squared plus bx plus c is graphed in the standard xy coordinate plane for real values a, b, and c. When y equals 0, which of the following best describes the solutions for x? So, if you are given a quadratic equation, what is the solution using a graphical representation? So what you want to remember is the connection between the solutions of a quadratic equation and what it looks like on the graph. Okay, so recall the graphical solution to a quadratic equation is what? The graphical solution to a quadratic equation are the, you can call them zeros, the roots, or you could call it the x-intercepts, however way you want to approach it. Okay, they're all talking about the same thing. So that's what the solutions are. Now, if you take a look at this graph, on the right side, this is the positive x, this is 0, and this is your negative x right here. So can you see where the solutions are? You have one solution here, and you have another solution here. One is to the left of the y-axis, and one solution is to the right. So what does that tell us? It tells us that we have two real solutions. Okay, as long as they are intercepts, then you're guaranteed to have two real solutions. Okay, so let's look at the options that we have here. It says two distinct positive, two distinct negative, one positive real, one negative real. J, two real solutions that are not distinct, that's like a double root, and then K, two distinct solutions that are not real. Alright, so what I'm going to do is I'm going to show you what possible solutions are for all 5 cases, and then you easily see what the correct answer is. Okay? Alright, so option F. If you have two distinct positive real solutions, what will that look like? If you have two distinct positive solutions, what's going to happen is that you have two intercepts that are to the right of your y-axis. So it's going to look something like this. Oh, snap. Do it again. It's going to look something like that. Okay? So you see that both intercepts are to the right of the x-axis. So in this case, you're going to have two distinct positive real solutions. Okay? Now let's take a look at option G. You have two distinct negative real solutions. Can you visualize what that looks like? It's basically a quadratic function, a parabola, where both x-intercepts are to where? To the left of the y-axis. So something like this. Okay, so in this case, you have a root here, a solution here, and you have another solution here. Both of them are on the left side. Okay, so this is your y-axis. Okay, let's take a look at option H. One positive and one negative real solution. So what does that look like? It's basically a scenario where you have one intercept, x-intercept to the left of the y-axis, and another x-intercept to the right. So something like this down. Okay, so you have the negative one here, and then you have the positive one right here. And as you can clearly see, this is the correct answer. Option letter H. Okay, let's write down our description. The graph has one positive and one negative what? Negative x-intercept. So since you have one positive and one negative x-intercepts, and the x-intercepts are the solutions, your conclusion is, so there is one positive real solution and one negative real solution. Okay, and one negative real solution. Now, let's take a look at option J. You have two real solutions that are not distinct. What on earth is that? If you have two non-distinct solutions, you have something called a double root scenario. Okay, so let's go ahead and look at what that looks like. So if you have two non-distinct real solutions, it could be located anywhere, but the bottom line is you're just gonna touch the x-axis once, and you are going to go back in the direction you came from. So it's going to look something like this. Okay? It doesn't cross, it just touches and then goes. It's like a touch and go type situation. But these ones actually cross. Okay? So this is a situation where we have two real solutions that are not distinct. You have a double root scenario. Okay? And the last one, option K, you have two distinct solutions that are not real. Now this is the deal. When you have unreal solutions, they are always distinct. They always come as conjugate pairs. You can never have a scenario that you have a double root that's imaginary. It's impossible. Okay? So if you have imaginary roots, that basically tells you that you have no x-intercepts at all. What does that look like? Something like this. So here you have two imaginary real roots that are distinct. Alright, so if you look at the five cases that we have, option H is our correct answer. Alright, let's take a look at problem number 29. It says, what is the product of the complex numbers negative 3i plus 4 and 3i plus 4? So there's something that you really have to keep in mind for the ACT, and that is the powers of I. Okay? So one thing you want to note is that if the power of I is greater than 1, it must be reduced. So the question is, reduced to what? Now if you have I, that's okay. I stays as I. If you have I raised to the second power, that's going to be negative 1. Because I is the square root of negative 1, and when you square that, you get negative 1. I raised to the third power is the product of I and I squared, which is negative I. And then I raised to the fourth power is negative 1 times negative 1, which is positive 1. These are the four that you want to remember because every other power of I just follows the same cycle, okay, the same pattern. So all you just have to do is start right back here. This will be I to the 5th. This will be I to the 6th. This is I to the 7th. I to the 8th power. Alright, so the same pattern goes on and on and on forever. Alright, now with that in mind, let's go ahead and find our product. We want to find what the product of negative 3i plus 4 and 3i plus 4. Alrighty, let me show you the box method of multiplying. There are different ways that you can do this, but let me just show you how to multiply using the box method. Okay, this is just one of the many ways that you can approach this problem. Okay, so there goes my little box. So we have 3i. Let's put the first factor on top, negative 3i and 4. And then the other one is 3i and then 4. So we just multiply. This is a multiplication matrix. 3i times negative 3i is negative 9i squared. 3i times 4 is 12i. Negative 3i times 4 is negative 12i. And then 4 times 4 is positive 16. Okay? So negative 9, we now have negative 9i squared. These two terms in the diagonal are like terms. But guess what? They are opposite, so they add up to 0. So they're gone. Plus 16. Now, is this an acceptable final result? The answer is no. What's wrong? Remember, you cannot have a power of I that's bigger than 1. Okay, so we're going to have negative 9. I squared is negative 1, so we replace I squared with negative 1. Okay, plus 16. Negative 9 times negative 1 is positive 9 because minus times minus is plus. Positive 9 plus 16 is 25. So answer to number 29 is option letter C. Alright, let's take a look at question 30. It says the radius of the base of a right circular cone shown below is 5 inches and the height of the cone is 7 inches. Solving which of the following equations gives the measure theta of the angle formed by a slant height of a cone and the radius. Okay, so let's see. We have a cone right here. This is the radius right here. This area, this is the slant height. Okay, this is a slant height right here, and this is the altitude, the height of the cone. Now, let's go ahead and set up our equations. Before we do that, we need to state the relationship between any two sides and an angle of a right triangle. Okay, so something that's very important that you need to keep in mind for the ACT exam is SOHCAHTOA. Okay, well, what does SOHCAHTOA mean? Basically, SOHCAHTOA relates two sides of a right triangle with one of the acute angles. Okay, so you really have to remember this. So means sine is opposite of a hypotenuse, chi is cosine is adjacent of a hypotenuse, and toa tan is opposite over adjacent. Okay, so let's extract the right triangle that we're given out, and we are going to see which setup basically helps us to solve for theta, the angle between the slant height and the radius. So this is 5 and 7. Now, whenever you're labeling a triangle, to use SOHCAHTOA, you want to label it with reference to the given angle. So in this case, this is the angle under consideration. So the side that's opposite the angle theta is going to be called the opposite. So that's the O in SOHCAHTOA. The other side is known as the adjacent. In this particular problem, the hypotenuse is not given. We don't need it. We don't know it, so we scrap it. Okay? So the two players are O and A. Now, if you take a look at SOHCAHTOA, you ask yourself which trig ratio, sine, cosine, or tangent, has O and A in it. We can clearly see that the answer is tan, TOA. Okay? So what does TOA tell us? TOA tells us that tan theta is equal to opposite over adjacent. Alright, so since the adjacent is 5 and the opposite is 7, tan theta is simply going to be 7 over 5. The answer to number 30 is option letter G. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming ACT, do give us a thumbs up. Your positive feedback will be really appreciated. If you have any questions or comments about the contents of this tutorial, just place it in the comment section below, and I will be more than glad to support you. Do subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.served.com under test prep. Thanks again for watching and have a wonderful day. Goodbye.